The next big idea we're diving into for chemistry is solutions. What are solutions? Well, they're homogeneous mixtures of two or more substances in a single phase. Why study solutions? Because they are everywhere, from the cytoplasm in our own body's cells to the air we breathe, and from stainless steel to Kool-Aid, most of what we see every day is a solution of some sort. To better understand our world, a better understanding of solutions is key. Today's video is going to cover three different types of mixtures: solutions, colloids, and suspensions. Let's do a virtual field trip to explore the different types of solutions out there. Virtual trip number one happens in the kitchen for a common solution you've most likely made before: iced tea. Starting out with a glass of tap water, I add a scoop of iced tea mix, which has sugar, food coloring, and whatever the heck natural flavoring is. Once I give it a stir and all the solid mix has dissolved into the water, now this is a solution that is homogeneous, meaning it all looks the same, and it has two or more substances in a single liquid phase. Here's a couple of vocabulary words to know for this chapter: solute and solvent. A solvent is the stuff that other stuff is being dissolved in, which in this case is water. A solute is the stuff that's being dissolved, in this case, the iced tea mix. Trip number two, still in the kitchen. Isn't quarantine fun? Here we have a good old glass of milk, which, unlike the iced tea, won't let me see through it. Why is milk opaque? Well, if we were to look at milk through a microscope, what we'd see is that there are a whole bunch of tiny spheres of milk fat that aren't dissolved in the water. A mixture like this is called a colloid. It's not a true solution, as the milk fat, while mixed in, is not dissolved. These little bubbles of milk fat are the reason why we can't see through the milk, as the bubbles act like little prisms and deflect light in every direction, which is the technical name of the Tyndall effect. It's the same reason that you can't see through fog or smoke. Here, let's take a look by trying to shine a light through both the milk and river water. Virtual trip number three takes us to the St. Louis River. Have you ever noticed how brown the Nemadji or Pokegama rivers are? Do you ever wonder why they are that way? If so, you're doing science. Remember, step one is observation, and step two is coming up with a question. After we get this pesky ice out of the way, we'll have a sample of fresh river water and see what we can learn from it. It looks brown and cloudy, doesn't it? If the brown stuff in the water were all to precipitate or fall out of the water and to the bottom of the glass, this mixture would be called a suspension. Suspension means that whatever is in the water is only temporarily there and will settle out on its own over time. What's the difference between a colloid and a suspension? Colloids won't have stuff settle out over time, and their particle size is small, while suspensions will settle out over time and their particle size is bigger. Honestly, I had thought that if I let the water sit for long enough, that the brown color would go away and we'd see a whole bunch of brown crud at the bottom of the glass. Looks like there is brown crud at the bottom, but the brown color of the water remains. What does this mean? Is the river water a solution, a suspension, or a colloid? Let's give it the light test. Don't think that all solutions are in the liquid phase. It's true that the ones we're most familiar with are, But check out tables 1 and 2 on pages 402 and 404 of your book. As long as the substances are in the same phase, solid, liquid, or gas, they're a solution. What do you need to know? Well, number one, solutions are huge parts of our lives and we need to know how they work to understand our world. Number two, solute is the stuff that's dissolved and the solvent is the stuff that things are dissolved in. And number three, I should know about solutions and suspensions and colloids. Last but not least, the Tyndall effect, that cloudy look that you get when you shine a light through a colloid. If you know all four of those, you're off to a great start for Chapter 12.